All right. So my name is Dimitris. I've done open source for like 25 years plus, and we made JBoss. Do you know JBoss? Yeah, okay. And then 7 years ago, we started Quarkus, our next generation framework. So, in Archinologos, and in the beginning was the prompt. So what happened like a couple of years ago, ChatGPT came out, and then we started talking to the website, the web app of ChatGPT. You put some prompt there. The prompt goes to the serving API. So there is an inferencing server running the model. We send the prompt. We get back a reply which is non-deterministic. And that's fully stateless. So LLMs know nothing about, they have no memory. And how do we solve the memory problem? We add a memory. But the memory is part of the application. So when you go to chatgpt.com, there is some middleware there that has a memory. And then every time you send something to the model, you get back a reply. You send something again, then the whole conversation is sent to the model. And this is the context, and it keeps expanding as we go. And that's how we solve the memory issue. And then if you want to do more advanced stuff, you do RAG. Have you heard about RAG? Okay, retrieval augmented generation, which is a glorified way to say, you know, I want to send extra stuff with my prompt. And how I get that extra stuff? Lots of ways, vector store, databases, whatnot. But at the end of the day, through some mechanism, you get some extra information. So let's say you want to query a contract. LLM doesn't know the contract, so you need to find the contract and stuff it with a prompt. And it's all text. There's no magic there. It's all text hidden underneath your prompt, and that's how all RAG systems work. And this is great, but you know, kind of boring. If you ask our friend here, and why it's boring? Because you just have a chat assistant. Like, the AI can't really do stuff. And when we say do stuff, we mean access the real world. So get access to an API, to a database, to a system, something that the AI can call, essentially. And that would make the AI become an agent. And when we talk about agents, we really talk about the agency of the AI, the ability to decide to do things. You know? So let's say we're in a travel booking scenario. We have a customer database, bookings database. So imagine having to give the AI access to this system. How will we do it? And the solution to that came a year after GPT went out into 23 through the function calling ability. Do you know about functions? Excellent. You're in the perfect place. So what happens here is the AI obviously doesn't have access to anything, but our application has. So what we do is we advertise to the model a series of functions that we provide. So we say to the model, look, I give you access to a method called get customer, get booking, change booking, delete booking, whatever, you know, make booking, something like this. And I give access this to you. So then when I ask you something, you can reply in a normal way, or you can reply to me saying, look, can you call this method for me and give me the result the next time you call me? And then this goes into the context and the conversation. So besides the text, we can send out the tools we provide, and then every time we call something, we send the result. And the LLM can essentially do stuff by proxying, by proxy, or we are the proxy. So let's say, look at an example. Let's say we ask the model, what's the weather in Athens today? And together with a prompt, we send this piece of metadata saying, look, I give you a function called getWeather. And it takes a parameter called city and unit, if you want it in Celsius or Fahrenheit. So I send to the model. The model has no idea what's the weather in Athens, but I gave it a function. So it says, oh, you know, can you call this function for me, for Athens, in Celsius, and tell me the result? the call comes back to the client, the client calls the function and sends back the whole conversation again with the results of the function call. And then the LLM can say with confidence, oh, it's 22 and sunny in Athens today. Maybe it's cloudy, but you get the point. That's how the whole magic is done. That's how all agentic systems are implemented under the hood. So, that's great. Now I have access to some stuff. I can do things. I'm closer to Skynet vision. But there are some limitations. And what's the limitation here? Your application, or ChatGPT or whatever, needs to integrate with everything it wants to integrate. And in some ways, it's easy. If you use Quarkus, it's super easy. We offer 800 integrations. But imagine you have to repeat this for every integration. So if you have N applications or agents and M systems you want to talk with, you have all the combinations. So it's it's explosive, like N times M. So to solve this, you can use MCP, Model Context Protocol. So what's MCP? Was created last year by Anthropic, basically as a way to do plugins for Claude Desktop. Okay? But it really caught up really quickly. Everybody liked it and started creating MCP servers, and it became like a de facto standard. So you can think of it like the USB for LLMs. So with MCP, the N times M problem becomes an N plus M, because as long as you implement an MCP client, you can talk to any MCP server available. So it facilitates really how we provide capabilities to LLMs. Now, how MCP looks like? If you are a server, you can offer those things. So the primary and most important one is tools. In MCP parlance, functions are called tools. So your server will provide access to something. So let's say a get weather function, or a database, or a file system, anything. You can model with MCP and anything. There are also some stuff about resources, which is like read-only access to files or calendars or pictures, whatever. And then prompts. Resources and prompts were really meant for the desktop Claude scenario where, Claude, let's say, has access to some stuff, or a coding assistant, and he wants access to the file system. And then prompts is a way for the server to say, look, to use my tools, maybe use this prompt with those parameters. So if this MCP tool supports booking travels, maybe you want to ask the user where they want to go, how long it's going to be, how much money they want to spend, and what do they like. But for the most part, when we talk about MCP, we talk about tools. Everything else is, extra. And in the latest versions of the protocol, the client can also provide some stuff to the server. So it can tell the server, look, you have access to this part of the file system. If I am a coding assistant and I give you the route to my project. Or it can do sampling, where the server can ask the client to say, okay, can you call the LLM and give me the result? Which I think is a very bad idea, because in my mind, tools, MCP servers are meant to model the boring part of the system. So like an integration to an ERP, a database, something like this. There's also elicitation, where the server can ask the client to put out a pop-up in the screen and say, I'm an MCP server talking to GitHub, what's the GitHub name? But again, you can see those are meant for, desktop-type applications, which, if you're doing server-side stuff, you don't care much. Now, MCP support different ways to be called. The easiest one is standard I/O, where the client will fork the server, will spin up a server, and they talk over standard input, standard output is the easiest local mode. And then you can talk over the network. So MCP initially provided an API where it's HTTP with server-send events, which was a very bad idea, and it showed what happens in AI right now. There are a lot of AI people that want to do middleware but have no idea about middleware. So they will repeat the same mistakes we did like 20 years ago. So they had to redo this. They did the streamable HTTP and SSE API, which is like the latest one, which supports more features. Yet there are still security issues. Anyway, you don't have to worry too much unless you want to implement an MCP server or configure an MCP server. But that's the status now. Now, MCP and Quarkus, I had slides, but I thought, maybe I just code the thing, otherwise it's going to be a very boring presentation. So let's code something. And to do this, we'll start from scratch to show you, there's no magic here. So this is the website for Quarkus. Anybody use Quarkus? Well, after this, you will. There's this button here, start coding. You can go there and look at all the possible integrations we have with Quarkus. We have 800 plus integrations. So you can do web stuff. If you want to do AI stuff, you look under LangChain. We have integration with all the popular APIs, all the popular vector stores, extensions to do RAG, and extensions to do inferencing in the virtual machine. So a lot of stuff. So you can say, OK, I want to talk to ChatGPT. I can use the OpenAI extension. If you want to do MCP stuff, filter for MCP. Let's say that's the client side. And for the server side, you have a different implementation. So we can pick up this one. So here we have picked 4 extensions for our application. You can generate it, download, and it should be here. So just unzip and switch to that directory. Not here. Oh. It has a life of its own, yes. Sorry. Let's do it from the correct directory. So, all right. So I'm connected to the local internet. So let's see if that works. So the way you code with Quarkus is you can start Quarkus in a special developer mode where it provides you with extra stuff. So this sample application is compiled, and if I press W, now I'm talking to my little Quarkus server that has the stuff inside. So there's a nice UI where you can see all the little components that make up this small app. It's an immense number to make you realize every time you use something, you use a lot of stuff, in fact. Those are the direct extensions I'm using. And in this mode, you can start, you can configure your server. So you can say OpenAI, timeout. Yep, let's use a timeout. Let's longer. And then if you want to log stuff, I want to log requests and responses. And every change I make here is applied to my code. So this is what I changed in the dev UI. It's in the code. It's live. And then those are the different extensions that make up my little application here. And you can, maybe try to test it and say, can you do a Java? Come on. Developer in Athens with a cat. Why not? So what happens here is I chose like an OpenAI extension, and I have an OpenAI key in my environment, but nothing else. I didn't do any other code. So Quarkus has all their need to start talking to the API. So I could just, like a typical developer. Yeah, we're very inclusive here. OK. So that works. This sample app is generated with an endpoint called hello. So Quarkus says hello, and says hello because there's a little thing here that says hello. So if I change it from, let's say, hello from OpenConf, conf, come on, and you refresh here, you know. So this is compiled Java, you know, this is Quarkus magic. We've shown that many times. Okay, so let's do a bit of AI magic here. The way we have, it's actually pretty good, the completion. Let's say hello from name. I don't want this. So the way we do it in Quarkus is, you know, we define an interface to the LLM, and we let Quarkus implement everything that I need to talk to that LLM. So this will be my prompt. You can see it's already a template. We can, you know, substitute a variable name. And then to use this from your code, like if you code normally in Java, something like this. And you can just replace that and do something like, let's say hello from Dimitris. Yep. All right. So if I refresh now I'm getting a message that actually comes from ChatGPT. Now I'm talking to ChatGPT and I'm sending and receiving stuff. And to prove that, where's my log? If you look at the logs, you see, yeah, I'm talking to GPT-4o Mini. That's my prompt here. And that was the result I got. Like continuing with this example, let's do a new prompt. Let's try to find what time is it. What time is it? Oops. Is it? I'll call this time. Okay. That's the time. And try to call this new method. Path time. Okay. Let's try to find the time. So what you think is going to happen here? It doesn't know the time. LLM has no notion of space and time. It just doesn't know. But we can help it by give him a function that returns the time. So let's implement a function there. That returns the time, sorry. So this is the standard code any junior developer will write, get current time. Just a class that returns the current time. Yeah, no magic here. It starts to become interesting if I add a tool annotation. So with this annotation, I'm saying this method, I can make it available to the LLM. And to connect it with my prompt, I can say, no, for this prompt, use tools that you can discover in this class. Sorry, that's it. Class name, greater tools.class, yeah. So scan this class and look for tools. So if we ask the same question, it knows the time, which is magic, right? So what happened was, you can look at the logs. So where is it? So this is when the LLM said, yeah, I'm sorry, I don't know the time. And the next time we've asked, we said, okay, what time is it? But we also said, look, I give you this function. And the LLM thinks about it and says, could you call this function for me? And then next time, we send again the conversation. We ask what time is it, we gave you a function, you said, call the function, we call the function, that was the result, and that's the metadata again. And then you can say, oh yeah, well, now I know the time. So this is how all this agentic thing happens behind the scenes. And now the thing is, we didn't do something very difficult, but because we have chosen the MCP server extension, what I just made is also an MCP server. And to verify that, we can go here and say inspector. Inspector is a utility, I think it's a Node.js one, that they provide when you write MCP servers to just talk to them and see, if everything goes well. So we're talking the latest version of the protocol. We're connecting to the local host, like on this thing. And let's see if I can connect. Yes, we can connect. So we connected with the Node.js app to the server. We can list the tools. The one we just wrote, get current time. And I can actually call it. Yeah, and I can give the result. So I just created an MCP server from scratch. So what if we want to do an MCP client? All right, let's look at that scenario. So I think I can close this here now. I don't need it. Disconnect. Okay, and go back to the code. All right, how we do a client? Where is here? Okay. So let's do the weather scenario. So let's say, let's say we want to send the prompt. What is the weather like in city? Yeah, in some city. We will call this the weather method. We want a city argument. City. Okay. And to use that, the same hack we'll do here. And we call this weather. So weather. For Athens. Somehow I want to do these funny things. Okay, come on. Come on, go away. Okay. So what's the weather in Athens? Let's see. We ask what's the weather in Athens, and it doesn't know the weather in Athens as expected. So what if we provide an MCP server not written by us that can provide the weather? It just happens that I have one. So let's see, where was it? Where was my weather? So, yep. All right, so that's a weather MCP server written, I think it's Python. Sorry. So we run our server, and to talk to that server, we need a bit of configuration. So basically, we need to configure our client to say, where is the server? So the server is an HTTP server. It's running on this port. And if I go to my code, where is it? Here. Let's make it a bit nicer. All right. So this is the configuration I need. So basically, we will speak to the server over HTTP, and it's running on this port. Something I need to do also to enable this functionality. I need to connect it here. So I need to say, for this prompt, use tools advertised by this MCP server, by the weather server. And with that in place, this should work. Yes, it works. So what's the story here? We can look at the logs. The logs tell the truth. Well, there's a lot of logs, but anyway, you can see that the server was called. So we talk to the LLM, we provide the function, the LLM thinks, says, yeah, this function looks interesting, can you call it? We go back and say, oh, I have this MCP server, we call the server calls the weather service, we get the result, we stuff it in the prompt, we get back a reply. And that all works nicely. So to conclude, to implement MCP servers with Quarkus, you just do your normal code, and you say, OK, this method, I annotate it with a tool. I include the server, MCP server extension, finito. I don't have to do anything else. You may want to configure security, as usual. If you want to do MCP client, you point to the MCP client. You include the client extension. You wire this with your prompt saying, I want tools from this MCP server, again, or I can use tools from all the MCP servers that you have configured, and that's all you need. If we go back to the dev UI, where is it here? You can see we also have a lot of functionality. Oh, look, MCP clients. We have functionality to test some of them stuff. So let's say this is our MCP server that we advertise, and we can call it like this. You can talk to your model. You have a chat API here. Hi, what's the weather in Crete? Yeah, it works. And you can see also the tool calls that happen behind the scenes. So I've asked this, and this tool was called, and that was the prompt I got back. There's lots of nice stuff you can do here. You can enable, disable RAG, and all that. So anyway, I think you get an idea. It's a new world. It's very exciting. In Java, you can do lots of things now and get by default all the nice things you get in Java. So, you know, speed, efficiency, backwards compatibility, security, performance. It's all there. If you like our project, you know, go check it out. It's all open source. So with that, I'm done.
Thank you. Thank you so much, Dimitris.
Thank you, Dimitris.
And most importantly, thank you so much for giving us your insight on how to build more capable systems.
Excellent speech, by the way. Thank you so much. A warm applause, please.
Yeah.